A second test that we covered previously were the dependent sample t-tests, and it was used to answer questions about paired data. So for example, before and after data is a very common study design. So each subject is going to be assigned to two conditions, before and after, for example. So each subject gives us two data points, and those data points are a pair. So the assumptions we had when we ran a dependent sample t-test were that the sampling was done well. In other words, it was random independent. And again, we had to assume that the population distribution was normal or that the sample size was large. And the question comes up, what if we don't know if the population is normal? Or what if we know the population isn't normal? What can we do? Or what if we have a small sample size? Well, what can we do? And the answer to that is we can use a non-parametric method, and the non-parametric method is called the Wilcoxon signed rank test, and sometimes it's just called the sign test for short. So the Wilcoxon signed rank test or sign test can be used in place of the paired t-test, which we studied previously. It's useful again when the population is not normal, or when the shape is unknown, like you're not sure if it's normal or not, or when the sample size is small, in other words, less than 30. And like the Mann-Whitney, it's based on the median of the population. The way the test statistic is found is you start by finding the differences in the pairs of data, and you don't care about the magnitude or the size of the difference, you only care about the sign of the difference, and that's why it's called the sign test or Wilcoxon signed rank test. So your null hypothesis is that the median difference is 0. In other words, there's no change. There's no difference in before and after. And the alternative is that the median difference is not 0. In other words, there is a difference. The test statistic is super easy. And again, it's usually done with technology, but you could do it easily by hand because all you're going to do is find the differences and then count the number of positive signs in the differences and count the number of negative signs in the differences, and you ignore any that are equal to 0. Now, if the null hypothesis is true and there's no difference between before and after data, then about half of the values should be above 0 and half of the differences should be below 0. In other words, we should see about half of the pairs with positive signs and half of the pairs with negative signs. If we see too many positive signs or too few, then we suspect that the null hypothesis isn't true. And so a question becomes, well, what's too many and what's too few? Again, that's going to be determined by our p-value. So the p-value in this sign test is found using binomial probability formula, and technology can find it for us, but it's interpreted in the usual way. So here's an example. A study was conducted to determine if it's easier to read words printed on colored paper than words printed on white paper. So 10 subjects were asked to read a passage printed in black ink twice, once on salmon-colored paper and once on white paper. And the time it took to read each passage in seconds was recorded. So here's the data. So this is subject number 1. On salmon paper, it took 79 seconds, and on white paper, it took 72 seconds. Now, if we just do salmon minus white, the top number minus bottom number, that would be a positive difference. For subject number 2, they also have a positive difference. So does subject number 3. But let's take a look at subject number 4. For subject number 4, they read 112 on salmon and 120 on white. So if we take 112 minus 120, that gives us a negative value. And again, we would just continue along this way, looking at our differences and determining if they are positive or negative. Now, in this case, there were 10 subjects, and what we got were 8 positives and 2 negatives. Now, if there was absolutely no difference in this colored paper speed, we would expect about half of the time, half the people to have positives and half the people to have negatives. So we would expect about a 4-4 split, or maybe a 5-3 split. But we found an 8-2 split. And the question is this significant? Well, using technology, the p-value that's associated with 8 positive signs is 0.002. So you would reject your null hypothesis, and your conclusion would be that the evidence suggests that, yes, there is a difference in reading speed. And that's the sign test. And that's so the two tests that we covered today, the two new tests, were the Mann-Whitney test, which replaces or can be used instead of a independent two-sample t-test, and the sign test, which can be used to replace the dependent sample t-test.